Good morning. I'm going to talk about solving word problems today. Now, I've shared with you on Google Drive a worksheet on solving word problems, the notes, that is. And in those notes, there is an example done out. The first part of it is name it, express it, relate them, solve it, and substitute in to answer the problem or solve the problem. So those are the 5 steps for solving equations, word problems, that is. And this particular worksheet is word problems with 1 or more numbers. Now, the first problem that we have on that worksheet, it says 1.6, and this is from an old Algebra 2 book. So this is not your green covered book that you usually use. So we're just using the worksheets out of this. If 18 is decreased by the sum of a number and 6, the result is 4 less than 3 times the number. Now, if you read that really quick, it's not going to help you. It's going to make it very complicated for you. So take your time when you read it. The first thing we need to know is, what are we talking about? We're going to name it. In this case, it is a number. So I'm going to name it by saying a number. Now, this only has one number in it, so this is not the more numbers. So we'll get to those eventually. I'm going to do 7 of these problems in this presentation, and you will do the remainder of those problems out of the 16 on the worksheet. So you'll have 9 for this assignment. The next part is to express it algebraically. How do I express a number with a variable? Let's call it x. So now that we know we're talking about a number called x, or whatever you choose as a variable, the next part is to set up an expression representing the situation. That's called relate them. That's what I use that term for, relate them. So it says 18 is decreased by. 18 is made smaller by. So decreased by the sum of a number and 6. Now, sum means to add a number, x, and 6. So we could say x plus 6. But if you're decreasing by that, you have to put it in parentheses, or you're only decreasing by x and then adding 6. So you have to decrease by x plus 6, the sum. The result is, those words, the result is, equals. Is typically means equals. Be very careful with that. Make sure the phrasing is correct for it, but the result is means equals. What does it equal? 4 less than 3 times the number. Less than is reverse order, so we're subtracting 4 from 3 times the number. So that's how you set this up. Then you just solve it from there. So, for example, distribute the negative. 18 minus x minus 6 equals 3x minus 4. Then we're going to go ahead and combine like terms. So negative x plus 12, negative 6 and 18, equals 3x minus 4. I'm going to go ahead and add x to both sides. So I have 12 equals 4x minus 4. I'm going to add 4 to both sides. So I get 16 equals 4x. Now I'll finish it off by dividing both sides by 4. X is 4. I've solved it. Now I have to substitute that back in to answer the question, and the question was find the number, basically. And so x is 4. That's how you do that part of it. Let's continue on to number 3 for our next example. I'm going to use these steps again in number 3, but I need a little more room, so I'm going to erase all this. Good thing you have YouTube where you can pause it as needed. All right. So in this next one for number 3, the greater of two numbers. Now, how many numbers are we working with? 2. What are we going to call them? Greater and smaller, just like the book says. Sometimes it says one number and another number, so we call them one and another. But greater, smaller. The greater number is 10 less than 3 times the smaller. 10 less than 3 times the smaller. Now, how did I decide that the smaller would be x? Well, which one was not talked about? The greater is, but it never says the smaller is in that. So the smaller is our variable. Whichever one's not talked about, that's your variable. And then use that to represent the greater. Now it says if the greater is increased by twice the smaller, the result is 8 less than 3 times the greater. Even saying it that fast is too fast. So the next thing I want to do is I want to write this expression out using the words greater and smaller instead of the expression first, just to show you how this wording translates. The greater is increased by twice the smaller, twice meaning 2 times the smaller. The result is 8 less than 3 times the greater. Eight less than 3 times the greater. So you can see that's the setup. Now we just have to fill in each of these expressions, greater and smaller, and we get 3x minus 10 plus 2 times x equals 3 times 3x minus 10 minus 8. So I've substituted 3x minus 10 wherever the greater was, and x for wherever the smaller was. The next step in my process is to solve this. So 3x minus 10 plus 2x equals 9x minus 30 minus 8. Be very careful when you're combining like terms. When I first did this one, I saw this negative and thought to apply it to the 2. No, 3x and 2x makes 5x minus 10 equals 9x minus 38. Negative 30 and negative 8. Now I'm going to combine, bring the 5x over, minus 5x. Negative 10 equals 4x minus 38. And then I'm going to add 38 to both sides. I get 4x equals 28. And then I divide by 4. X is 7. Now I have to answer the question, and the question is, what are the two numbers? So in this one, x is 7, and now 7 is still x, so 3 times 7 is 21, minus 10 would be 11. Now if I actually put those numbers back in, 11 plus 2 times 7, 14, 11 and 14, 25. And if I put the greater, 11 times 3, 33 minus 8. 30, did I do that right? 33 minus 8. Yeah. Yeah, it's 25. I don't know. Sorry. Second guessing myself there. All right, so that's how you do a problem with all 5 steps. Now I'm going to erase this one, and I'm going to do number 5. These are slightly longer videos because I want to make sure that I'm going through enough of these problems, and that takes a while. Number 5, we're talking about the second of 3 numbers is 4 times the first number. The third number is 12 less than the first number. Find the 3 numbers. Well, really what we're talking about is 3 numbers named first, second, and third. So I'm just going to say first, second, and third. Now I need to express them. And let's see. Which one's not talked about? The second is, the third is, it doesn't talk about the first, so there's my variable. The second is 4 times the first. The third is 12 less than the first. So there's my setup for number 5. Now I have to write out the equation. Now in this one, the equation, find the 3 numbers given their sum, meaning adding all 3 of these up, is 12 less than the first. So I can, sorry, I read that wrong. Their sum is 42. I was looking at the wrong line. Their sum, so I have to add up these 3. Now you can write that out. $42. Or you could have started right away with adding these 3 up. X, 4x, and 1x make 6x minus 12. So you could have started here or there. Either one of those would have been absolutely fine. Then we're going to continue by adding 12 to both sides. And then dividing both sides by 6. X is 9. So x is 9, 36, and negative 3. It is okay to have a negative number in these. Had you been working with shapes and sides of a shape, you wouldn't want a negative result for the side. But in this case, it's not a problem. Now, I need to do some note-taking here on the next one about consecutive integers and consecutive multiples. So let's do that next. So when we're talking about consecutive integers, when we name them, however many we have, first, second, third, you could write out the word if you rather, fourth, however many you have, okay? The first integer is our unknown, so there's our x. The next integer, if you're going up by integers as you go along, so 1, 2, 3, 4, or wherever you start with, 75, 76, 77, 78, it's always, the next one's always 1 bigger, so x plus 1. X plus 1 is 2. X plus 3, x plus 4, all the way down, right? So that's how you do consecutive integers naming and expressing. Now, what happens if we're talking about consecutive even integers? Well, again, we're talking first, second, third, fourth, And again, we start with x. The next even integer is 2 away. So if this were 5, yeah. If this were 6, the next integer that was even would be 8. So x plus 2 plus 4x plus 6. And you keep going by 2. Now here's even more interesting. What about odd? First, second, consecutive odd integers. Third, fourth. A lot of people would tell you it's like x plus 1, x plus 3, x plus 5. Nope. Or x plus 3, x plus 5, x plus 7. Nope. If x were an odd integer, let's say it's 5, the next odd integer is 7. That's 2 away. So it's done the exact same way as the evens are. Oop. Done the exact same way as the evens. Now, you can see that even numbers are 2 apart, odd numbers are 2 apart. That's the reason. The last type, and by the way, when you're working with this, with these consecutive integers, a couple of things to be careful of, but the first thing that I was going to talk about, I kind of forgot, so I'm going to go to the second thing, and that is when you are substituting back in, say you put the first one as 12, then 12 plus 2, 14, right? Don't go 14 plus 4, because that's not the next, x is 12, not 14. So 12 plus 4, 16. Or just make sure you're going by consecutive even numbers. All right. Now, this says consecutive multiples of whatever, right? We don't know what the multiples are of yet. We'll fill that in. First,